Everything you have ever seen, every star, every planet, every galaxy, every cloud of gas and dust stretching across billions of light years, makes up just 5% of the universe. The other 95% is invisible. It does not emit light. It does not reflect light. It does not interact with light in any way we can detect. And we have no idea what it is. For most of the 20th century, astronomers assumed the universe was made of the same stuff as everything around us. Protons, neutrons, electrons, the periodic table, normal matter. Then in the 1970s, an astronomer named Vera Rubin pointed her telescope at the Andromeda galaxy and measured how fast its stars were moving. The answer made no sense. In our solar system, planets close to the sun move fast. Planets far from the sun move slow. That is how gravity works. The further you are from the mass, the weaker the pull, and the slower you move. It is the same rule that governs every orbit we have ever observed. But in Andromeda, the stars on the outer edge of the galaxy were moving just as fast as the stars near the center. Not slower, the same speed. By every law of physics we knew, that galaxy should have been flying apart. The visible mass at its center was nowhere near enough to hold it together at those speeds. Rubin measured hundreds more galaxies. Same result, every time. Something invisible, something massive, something completely undetected, was holding each galaxy together from the outside in. She called it missing mass. We now call it dark matter. Dark matter is not a small correction to our understanding of the universe. It outweighs all normal matter by a factor of 5 to 1. For every kilogram of stars, planets, gas, and dust in the cosmos, there are 5 kilograms of something else. Something that has gravity, but is otherwise completely invisible to every instrument we have ever built. It is not dark energy. That is a separate mystery, driving the expansion of the universe. Dark matter is different. It clumps. It clusters. It forms vast invisible halos around every galaxy, and vast invisible filaments connecting galaxies to each other across billions of light years. That structure, the cosmic web, is the skeleton of the universe. The places where dark matter is densest are the places where galaxies form. It is not a coincidence. Dark matter came first. The galaxies grew inside it, like cities built along existing roads. Without dark matter, there are no galaxies. Without galaxies, there are no stars. Without stars, there is no carbon, no oxygen, no chemistry, no life. Whatever dark matter is, we exist because of it. The honest answer is that we do not know what dark matter is made of, but we have candidates. The leading theory for decades has been WIMPs, weakly interacting massive particles, hypothetical particles that have mass and gravity but almost never interact with normal matter. Every second, billions of WIMPs may be passing through your body right now. You would feel nothing. WIMPs are elegant. They fit neatly into theoretical physics. They were predicted independently by particle physics before dark matter even became a serious problem, which made them seem almost too perfect. Another candidate is the axion, an extremely light particle, first proposed to solve a completely unrelated problem in quantum mechanics. If axions exist in large enough numbers, they could account for all of the missing mass in the universe. A third possibility is that dark matter is not a particle at all, but primordial black holes. Microscopic black holes formed in the first fraction of a second after the Big Bang, before any stars existed. Invisible, massive, scattered throughout every galaxy. And then there are the theories that say we have it completely wrong, that there is no dark matter at all, and gravity itself behaves differently on galactic scales than our equations predict. Modified gravity. Most physicists consider it a long shot, but it has not been ruled out. We have been searching for dark matter directly for 40 years. Underground laboratories on every continent house detectors cooled to within a fraction of absolute zero, waiting for a single dark matter particle to nudge a single atom. In South Dakota, the LUX-ZEPLIN experiment sits a mile underground, shielded from cosmic rays by solid rock, listening for a collision that has never come. At CERN, the Large Hadron Collider smashes protons together at nearly the speed of light, hoping to create dark matter in the debris. Satellites scan the sky for gamma rays that might be produced when dark matter particles annihilate each other in the centers of galaxies. Nothing. Not a confirmed detection. Not a single direct signal. Every time an experiment has been sensitive enough to find WIMPs, it has come back empty. The silence is not a failure of technology. It is a message. Whatever dark matter is, it hides better than anything we have ever hunted. The absence of a detection is itself a discovery. It tells us that if WIMPs exist, they interact with normal matter far more weakly than our best theories predicted. It has eliminated huge regions of possibility, particle after particle, mass range after mass range, ruled out. We are running out of places for the simple answers to hide. Some physicists believe that dark matter is not one thing, but many. An entire dark sector of particles and forces, a shadow universe sitting alongside our own, interacting with us only through gravity. A cosmos we will never see, never touch, and never communicate with. Present everywhere, knowable by its effects alone. It is possible we never find it. Not because it does not exist, but because it is simply not the kind of thing that leaves a trace we can read. The universe is mostly something we cannot name. Every telescope ever built, every probe ever launched, every detector ever cooled to the edge of absolute zero, all of it has illuminated 5% of what is out there. The rest remains exactly as it was before the first scientist ever looked up. Dark matter has shaped every galaxy you have ever seen in a photograph. It determined where stars would form, where life could emerge, which corner of which spiral arm would eventually produce a planet with something on it capable of wondering what the universe is made of. We are here because of something we cannot find. And somewhere out there, in the dark, the answer is waiting.